So we want to solve 4x plus 5y equals 35. 2y equals 3x minus 9. I'm on page 2. Hopefully you're following on. We're on the back. Yeah. All right. So what's the first thing I got to do here before I can do any of this stuff with the elimination? Cassie? Yep. Rearrange so that the like terms align. So what would you do for this? You have two choices. What do you think you would do? Because you're going to take this guy and subtract him so that effectively moves it over here. We have the x plus the y equals the number. So let's see what we get. That won't change the top. But on the bottom we've got negative 3x plus 2y equals negative 9. I had another choice. We could have said, well, why don't you just move this guy over here? 5y equals negative 4x plus 35 and then this pair. Either way is correct. Either way that you see it is fine. Great. Now I look for opposites for the x's, opposites for the y's. Do we see any? I don't see any either. So what is it we can multiply by so that we can make either the x's be opposites or the y's be opposites? What do you think?
I think you can multiply 4x by, or 4 by 3.
Multiply the 4 by 3.
And then divide by 4.
Okay, so if we do that, I'm going to get a 12x here, a negative 12x, so what's that going to do for us? It's going to eliminate the x's, right? Now what I do like to do is kind of check this out as well, because you never know, maybe the y's are easier. It was easier in the last example. If I wanted to eliminate the y's, what would I have to do? What could I multiply by if I want to eliminate the y's? Yep.
We multiply the top by 0 and bottom by
Negative 5. In this case, that would give me 2 times 5 is 10y. I'm making it negative because the signs are the same. So by making it negative, I'm going to have opposite. So using this multiplier will eliminate the y's. Well, which one should we use? Either. Does it matter? No. And then it comes a point of, well, which one looks like it might be slightly easier? I don't know, this one, 6-1, half dozen another. Which one do you want to do, Asa? You want to do these? All right. So let's multiply through by 3. Remember, what gets multiplied through by 3? Everything. Oh, I'm going to need some calculator help here. 12x plus 15y, 35 times 3. The bottom one multiplying through by the 4. 4 times 8y. Check for my errors here. Sometimes I make a lot of mistakes. I got my opposite, so I can just add. Eliminates. 23y equals 50 minus 7. Not that one. Divide both sides by 23. Y equals 3. So again, I'm building my solution. The y is 3. How do I find the x? I go back up to an original to try and find the x. Pick either one. I'm going to go with 2y equals 3x minus 9. It doesn't matter. You could have done the other one. 2 times 6 equals 3x minus 9. Great. That's why. 2 times 3, so that's a 6. Add the 9. 15 equals 3x, so 5 equals x. Symmetric property of equality. Let's turn that around. I'm getting 5, 3. How would I know I have the correct solution? You're going to plug the 5 in here and the 3 in here. You're going to plug the 3 here and the 5 in here. So 4 times 5 is 20, plus 5 times 3 is 15. 20 plus 15 is 35. 2 times 3, well, that's 6. 15 minus 9 is also 6. So it does work. Check it in both. We have found our solution, 5, 3. Okay, questions on that? Yes?
How do you guys multiply the two equations?
How to multiply this one? If all else fails, you can always multiply this one by that, and that one by this. This one by that one by this. or look for a least common multiple. And if you're having trouble thinking of that, think of fractions. If you were adding 1/2 plus 1/5, what would you use for the common denominator? 10. So it's the same thought process. I want to turn this into a 10. So that would be a 2, that would be a 5. The last little thing to remember is that we want is opposite, so that's why I want to do negative. We're going to look at some other examples too. Okay? I want to do a word problem as well because I want us to not be afraid of them. So let's see what's happening here at Brenda's school. They're selling tickets to the spring musical. On the first day, they sold 3 senior citizen tickets and 9 child tickets, making $75. They made $67 on the second day by selling 8 senior and 5 child tickets. Remember, these problems are very, very similar setups. You want to declare variables to describe what you're looking for. Here it says, what's the price of a senior citizen ticket and a child ticket? Those are your unknowns. So let X equal the price of a senior citizen ticket, and let Y equal the price of a child ticket. It is important to declare these. It helps you keep it straight in your head. So I do want to see a statement like this. Now we look up here. What could the first equation be? First equation. Hey, give me the first one.
3x plus 9y plus 7.
Explain how you got that.
Since X is a senior citizen tickets, and they sold 3 of them, 3x, and we sold 9 child tickets, so 9y.
And they spent $75. So it's simple as just reading the question. What would the second equation be? Okay, what's the second equation?
It would be 9x. No, 5x.
Be careful here now. It says 8 senior citizen tickets. Which is your senior citizen, the X or the Y? The X. 8X.
Plus 5y equals 66.
So be careful with the questions. You might want to start circling things. You can make notes here. That's my X. That's my Y. Anything that helps you kind of keep them straight. So this was the so-called hard part. Coming up with the 2 equations. The questions on where these equations came from. Do you think you could do a question like this? I think you could too. All right. Now we just have to get to the business of solving. Yeah.
But how do you?
Well, you get to choose. So you could have made it the other way if you wanted to, just as long as the numbers correspond correctly. 3 is the number of senior citizen tickets. So whatever you call that, that should be times 3. So you get to choose. All right, great question. So what should we do here? I don't have any sames, and I don't have any opposites. So I need to do some multiplication. What do you think?
You could multiply the top by 8 divided by 2. So then you could multiply the top by 5 and top by 9.
Okay. Hey, answer both parts. So if I do that, I'm going to work on eliminating x's with the 8 and the 3's. The 9 and the 5's, I'm going to work on eliminating the y's. Which one do you prefer?
I did
8 and 3. Okay, we can do that. Now, what's one slightly better than 8 and 3? Because that gives me 24x, 24x. What's slightly better? Because I like to add. I don't like to subtract.
Don't say that. I like to subtract.
What do you think?
I just do anything that is good.
Make it negative. Okay, make it negative. And now I'm going to multiply it. I definitely need some calculator help here. So I can do the small numbers. That's 24x plus 72y. What's 75 times 8?
5.
You do have a calculator, right? Look at calculators. Type it in. All right, that's that one. Then what's happening on the bottom? I'm doing a negative here, so I'm really trying to be careful here with the negatives. But I do need to know what negative 3 times 67 is. All right, now I can do my adding. Eliminate the x's. 72y minus 15y. That's 7 and 57. Equals, that looks like 399. So I have to divide by 57. That's probably going to be Horrible number, huh?
Six.
What do I get?
4.2.
No, 399 divided by 57. Isn't that nice? So what's that? That's Y is 7. Go back to your little mapping here. Y is your senior citizen ticket. So by writing these out, it's helping me keep track of what's what, and I put it in the wrong spot. No, I didn't. Y is the child ticket. I'm sorry. Child ticket. Now, if I do want to find the senior citizen ticket, I pick one of these. And I get 3x plus 63 equals 75. I'm subtracting the 63. Looks like 12. Divide both sides by 3. X equals 4. So that's my X, which is the child ticket. So the child ticket costs 4. The senior citizen ticket, I'm sorry, that was 7. Senior citizen ticket was 4. Child ticket was 7. Plug them back in here. Make sure those equations work, and you have solved the problem. Any questions? Good.